Madeleine from JetDev. Today I'm going to show you how to create a cloud server on Hetzner using Terraform. And Hetzner because it's damn cheap, and for me, for more than 10 years, it proved like it never fails. I have servers with them that are running for many years, and they barely had probably a couple of hours in more than 10 years now of downtime. So let's get cracking. Probably you're looking at this because you know Hetzner already and you want to try it out, and you want to try it out with Terraform. So we are going to spin up a CPX11 with the minimals possible in one of the regions, and make a little bit of tweaks about how it is started from beginning to be a little bit more secure, and you would understand how to use those things to personalize it for yourself. In your cloud console, what you need first to ensure you're going to have into a project, right, because there is a separation between projects, you need an API token. You must make sure that it is a read-write token, and just give it a name to recognize it later. Copy it because you won't be able to see it again. Make sure you copy it. Right. What we are going to do in Terraform, we are going to initiate the Hetzner Cloud provider and start a single server with minimal configuration. What are we going to use to make a pre-configuration for it? We are going to use Cloud-init, a technology developed by Canonical, the people that bring us the modified Debian distribution named Ubuntu. And here is a little example that you can find in the description, the link to it, where you can figure out somehow kind of like how do you create yourself a default user, how you inject a public key directly into it, and how you disable root access on SSH, how you disable the password access, password-based access, and tweak a little bit further SSH to be a little bit more secure by changing the port, and here by saying yes or no to certain things depending on your needs, like for example permit tunnel or allow TCP forwarding. Set them to no if you want to be more strict, let them yes in case that you need them. So okay, so let's get cracking. To manage a project, usually I'm creating a directory. And inside this directory, what we need to do for Terraform is to have a Terraform file. The Terraform files can be named almost with anything, ending up with an extension with .tf. I'm naming usually my starting file, the first file, I'm naming it main.tf, just as a habit coming from Go development. So within this, what we need, and I said that must not forget about the token key. Let's have a text file. I'll have a text file here. I'll have it here. Don't worry, you can't use this one. It's going to be deleted after the video. So what we need here is to initiate the provider. Copy paste this, and we will go further after this. So this ensures that we are going to have Hetzner, and here we can actually tweak a little bit. We can tell that we would like the latest, and we can actually see how it's going to work. I would trust version major 1, and I would trust that I would bump up the minors and the patch level as often as it can. So probably I would stick to this. in the provider, we need to add something that we can find on the page of documentation, named that it expects a token, the token that we are going to add from where we created it in the panel. So it expects a token, but as for best practice, it should be coming from a variable, Cloud. It can be named as you want, but this is just to ensure that I'm getting it. And I'm going to set it here, var Cloud token, variable. And what we want to tell to this variable is that it must be sensitive. So sensitive means that it's not going to be exposed in logs or console while it's running. So just to keep it outside of different eyes. Okay, so what we want now is to create a server, and the documentation for creating a server is on Cloud server within the resources. Here you're going to see resources and data resources. This is to read actually state from the other one, but that's in another video. How do we read the state from a manually created resource in Hetzner? So let's create a server, and the most basic thing what we need is this part. So in the same file, I'm going to go here down and create a server, node name. I want a more recent distribution, and I want it on CPX, because next, instead of this, which this is the default as well, to give me an IPv4 and an IPv6 public network, I want to tell it that I want it in a certain location, because here we can see arguments, references, name is required, so the name must be like a host name, a valid host name. Server type is required, image is required. Okay, so we had 3 until now: name, image, server type. Okay, and then location is optional, and we can use from the European locations or the American location ASH. And I think we've got the new one, hill. Also, we've got hill. Let's try hill. Location equals hill, and I think it's hill 1. No, actually, it's only hill, because we can clearly see that here it is ash, and the other one is hill. Okay, so location hill, and we are going to see if this would work. So Terraform plan. Okay, I've got an error, so it doesn't like to write the versions like that. Okay, let's get to the examples. And okay, it's asking me for that variable that I declared, but I didn't give a default value. And we saved it here. I'm going to copy, paste, boom, enter. Okay, inconsistent dependency log file. I didn't initiate Terraform. Yes, Terraform init. This is happening every time you are coding, you are writing, and nothing works perfect like in video tutorials. So I'm trying to do this on the fly, exactly how I'm doing every time. Reading documentation, writing, experimenting, trying, getting exactly to there. So we've got a log file. Okay, and now if I do the plan, put the key again, it's going to try to create this. Okay, let's apply it. Put the token again, yes to accept, and it's going to create the server. But the server that's going to be created, it's going to be created with only the user root and send the password over the email to us. Now I'm going to check my email, and yes, the server is already created. I can so here within the servers I've got node 1, and this is its IP. It's in Hillsborough, United States, Orlando. I've got an IP, and if we try to SSH into it, we're gonna have to use the user root, and it should allow us, asking us for a password. I received the password over the email. I'll paste it, and I'm in. It's going to ask me to reset the password. Okay, so I'm in, right? You can see it's one single server with almost 2 gigabytes of RAM and 2 virtual CPUs. Virtual CPUs meaning 2 threads. Like if you know Intel and AMD hyper-threading, it's actually one core with 2 offering 2 virtual servers. Okay, but I want everything to be by default configured a little bit more restrictive. So I'm going to kill this server. I'm going to destroy the current thing that we did. It's still requiring me to put this token, so we are going to learn also how to avoid the question for the token every time. Destroy everything, yes, and if we look now into our, oh, it's gone, you can see, okay, it's gone, perfect. And do I have anything left here? No, it cleaned. So Terraform created and then destroyed everything. So really quickly, really nice, avoiding the interface and forgetting what we actually did. Because this is state, this is how we want to tell it that I want you to put this and I want you to destroy everything. Okay, now if we look at the H Cloud server property documentation for an resource H Cloud server, we see somewhere down here that it is supporting user data that it is actually Cloud-init specific rules that we can put into a YAML file. And I said that I've got here an example of a minimal one which makes a much more secured by default cloud server. So I'm going to copy paste this and adapt. Now user data.yaml. Okay, paste this. And what are we looking to change? Well, you want a name for your user. I'm going to name this peon. I want a primary group for this user, peon. Probably this can be skipped and it's going to by default create it. Let's try it. Let's actually try it. I'm usually a little bit explicit. I never tried it without. I'm just going to leave it. And then you can insert your public keys for this user either by using SSH import from GitHub or Launchpad. I'm not recommending using the GitHub because sometimes works, sometimes it doesn't work. Cloud-init will not wait for the server and it's not going to retry for half an hour if GitHub has issues. So if the keys are not provided on the simple HTTP GET request to your username.keys, simply it's going to skip. So the safest way is actually to put here your SSH key, and I'm going to grab mine. I'm going to grab mine from my SSH which is this. You can also read them by using cat.ssh id, and if it's id type or RSA with that pub after, and you can copy it, right? So either way works. So I'm going to add it here, remove the first part, and log the user password. So user doesn't have a password, but it's fully usable. Make him use sudo and no password, because in the near future I would like to use this with Ansible, and it's much easier with no password. And it is safe because we are going to disable root access through SSH, and you can become root if you are already logged in, but it won't allow root to log in any way, and it's going to disable password authentication. Next, it's going to write an extra SSH config file, which is loaded by SSHD. This is loaded at the beginning of the normal SSHD config. So make sure that nothing is overwritten by SSH config that the cloud provider offers the server. It might be so, and I'm not really sure. Normally, almost everything in it must be commented out of the box with the defaults. So I'm overriding the port. So I'm setting a new port, and this is as an example 65432. Set anything underneath 65535 or something like that. So just a random port up to 60,000. It's great. Allow agent forwarding. Yeah, I'm strongly recommending this, because the moment that you would load SSH into it, you can forward your SSH agent, so you can use your private keys from your local transparently, and you avoid to put any private keys in this server. So this is a good configuration for a jump host, for example. Optionally, allow TCP forwarding. This is useful for jump hosts and development cloud servers. Permit tunnel as well. So normally on a production server, I'm setting this to no, and I encountered some public cloud providers that the TCP keep alive was not enabled by default, so I'm just enabling it here. Okay, so with that, the default user switched to peon. By default on Hetzner is root. On DigitalOcean, I think it's admin. Some instances in Amazon is admin. Some of our Ubuntu, if it's an Ubuntu distribution. User default. We will disable root on access on SSH, and we are going to disable the password authentication. Okay, so we got this. This means that we can add it to the main. And here, after location, I'm going to add user data equals, and we can read the file. And the Terraform command or function, normal name function, to read the file is file. And between double quotes, we put user data dot YAML and okay. Good. So if we run plan, we see again that our annoying question about the token is again, it would add this, and we see a hash around the user data that would be there. I want to show you something here. Make sure that the Cloud-init file, it's always going to start with hash cloud-config. So make sure that it is this. Don't try to put any other comment. Don't try. First line must be this, because Cloud-init, I think by default, or on a certain way of being configured by the public cloud, will ignore the data if it's not like this. Okay. Next, let's get rid of that token thing. So Terraform loads by default all files that respect a certain naming convention. If it's ending with .tf, it's going to load it and construct based on the dependencies whatever, how it must run one after another one, because you can write extremely, like in any file and any position you can write a resource and a state about that resource, because Terraform will calculate the dependencies and it's going to run them in the correct order no matter how you lay them out. It doesn't matter if they are going to be run in the correct order, because it's creating a dependency graph. And if you want to auto-load variables, you need to create files that end with .auto.tf-vars. So usually I'm creating a nano secrets.auto.tf-vars, and here I'm going to put hcloud token equals, and we've got this. And as I've got this little body, now Terraform plan smashing. It's not asking us for the token anymore. Now let's try to apply it and see if I was right of everything. Now this file secrets, I am usually put this file name in gitignore, so I'm not putting these secrets with git, so they are safe. We in the team we are putting all our secrets into a special key vault, so everything is safe. Okay, so let's apply Terraform. Apply, and let's see if it's going to work. Let's see if it's going to work. So the server is getting created. Let's go here. Our server is created. Most of the times you're going to see, if you destroy a server and you recreate the server in the same location within less than 48 hours, you're going to get the same IP. This is something related to people that are using mail and would like to try to spam or something like that. So they end up using the same IP all the time. Now, if I'm going to try to do what we did previously, you see, port 22 refused. Port 22 refused. Okay, so now let's put the port that we added. Smashing, yes. Okay, it allows me to connect to it. But the public key is not accepted. Okay, because in root we didn't add any public key. And you see, it didn't ask me for a password. Because normally, if the public key fails, it should ask for a password, but we disabled password. And now we know that our user is Ion. And I'm in. And I can run as super user. And that's awesome, because from now on we can continue to a bunch of tutorials where we are going not only on a server, but I'm going to show you how to extend this recipe to create clusters for either horizontal scaling or horizontal or high availability concepts, or maybe a hybrid between. And we are going to take Ansible into it, and we are going to create nice clusters of applications that provide horizontal scaling for increasing performance when you get lots of hits, and for having high availability. And we are going to discuss for how to deploy clusters of MariaDB, a MySQL replacement, clusters of PostgreSQL, clusters of Elasticsearch or OpenSearch, how we can put stateless PHP applications, even ending up in how to run WordPress with dozens of instances for high availability and increased performance, and not get the brain damage of like, what do I do with the uploads? Yes, we are going to see all of them using these incredibly cheap servers. Because if you compare the price from here for 2 cores with 2 GB of RAM with anybody else, you're going to be amazed about the pricing and about what you will be able to do with the equivalent. Because the equivalent of them on that side is like premium AMD, and this is 2 $21 versus 45. So sorry, it's so cheap that I can't even pronounce it. Sorry. I mean, 21. Wow. And look, 20 terabytes of traffic, outside traffic, only 3. Slightly bigger SSD, not a problem, because if you're going to look on the volumes, where do we have volumes, price for volumes, the price for volumes is 4.4 for fast NVMe. And if we are going to look at the price for this, oh my god, it's actually 10 cents. Well, that means like 8.5 cents in euros. So you get it, it's like half price on volumes, and about 18 euros compared to 4.5. It's less than, it's 4 times it. Well, you get it, it's like 25% than DigitalOcean's price. So I hope I caught your attention, and now let's get cracking and let's learn how to deploy lots of things, and be in control. Have a nice day.